Okay, when you're curve sketching using derivatives or calculus methods, there's a bunch of steps that you need to follow to identify those special points that we talked about, all those turning points and points of inflection, and the features of the graph to identify the types of inflection features that they are. So first of all, you identify the y-intercept, so where the function cuts the y-axis. Second of all, where the function cuts the x-axis if possible. Third of all, vertical asymptotes. We're not going to do that here, but I've just left that in there. So we're going to go straight to the stationary points. So using the derivative, we find where it equates to 0, and those are our x points. Then we identify stationary points using either the second derivative or the first. Okay, so that's much the same thing. And then we find the points of inflection, which we do second derivative, that should say equaling 0. And then we check the concavity either side of those inflection points. And then we find the values of the stationary points. So we find the corresponding y points that we're going to put on the graph for those particular stationary points that we found. We look at the long-term behavior of the function of x. So again, if it's a positive overall function, so if y equals x squared, it's got this behavior overall. If y is negative x squared, it has an upside down behavior overall. For cubics, y equals x cubed, it tends to increase, turn around, and increase again. So overall, it has a positive behavior that way. So we're just really looking at if there's a negative or a positive value in front of the function. If y is negative x cubed type, then our graph will be heading down, turning, and down again. So it'll have a negative behaving overall behavior like that. So that's the bit we do at the end to make sure we've got all our directionals correct.